In this problem, it asks if the set of negative integers is a commutative group under the operation of addition. And if it is not, we need to say why it is not. Okay, so here we're looking at the set of negative integers. And those are the numbers coming from negative infinity, -4, -3, -2, to -1. So they have to be negative, they have to be integers. So the first property I'm going to check is the closure property. If I were to add any two negative integers, would I always get a negative integer? This is a little abstract. I can make an individual example. I can say -4 plus a -2 gives me -6. But just the fact that it works for one pair of numbers doesn't mean that it would have to work for all of them. So we just have to think about what we know about the negative integers. Is there any special negative integer that might make this not work? But any two negative integers that I choose, when I add them together, I will definitely get a negative integer. So we have closure. The next thing I'm going to look at is the associative property. And since my operation is addition, I know that this set has the associative property for addition. So if I change my grouping, I'll get the same result. And we can also say commutative for the same reason. When the operation is addition, then we can definitely say that we have the commutative property. So now we have the identity element and we have inverses. So let's take a look at an identity element. An identity element is a value that if I take that number plus any negative integer, because that's the set we're working with, so I'll say -5, I should get the same result as if I take -5 plus that element, and the answer should be -5. So we want this to be the same in each of those places. So what number would that be true for? Well, when we're working with addition, the identity element is 0. But the problem is that 0 itself is not a negative integer. So we do not have an identity element. And if we don't have an identity element, it's not possible to have inverses, because then I would need to have a number that I could add to -5 to give me the identity element, but we already said the identity element is not in the set. So, and in this case, this would be a +5, which is also, again, not a negative integer. So we're going to say no to identity and no to inverses, and if we have any of these properties that don't hold, then we're going to say it's not a commutative group. So I'm looking for no identity element, and that's C, and no inverses is E, and so that's my answer for that problem. Now let's take a look at another set. So here we have the set of rational numbers, and we want to determine if that's a commutative group under the operation of division. So when we look at closure, if I divide any two rational numbers, say A over B, divided by C over D, do I get a rational number? And for the most part, that's going to be true. If I take 2 over 3 divided by 1 over 7, Well, that's 2 over 3 times 7 over 1, and that gives me 14 over 3. So my one example seems like it's going to work. But here's where we run into trouble. Whenever you see division, 0 is going to be the thing that gives you a problem. So if I take 2 over 3 and I try to divide that by 0, or 0 over 1, I can't do that, right? This is undefined. So it's definitely not a rational number. So we do not have closure. Most of the time, you're going to get a rational number when you divide two rational numbers, but not if you're dividing by 0. And so it's not closed. So let's see, that would be E. Next, we look at the associative property. We know that we have the associative property of addition and multiplication, but not subtraction or division. So I'm going to say no to that. And at the same time, I'm going to say no to commutative because that's the same deal. So B is about the associative property. So I'm going to check that. That's not going to work. We can't change the grouping when we're working with division. And it is not a commutative group because it's not commutative. That's choice number C, or choice letter C. And that is a division sign in there. It looks kind of like a plus. It's very tiny. So we said no to those. Is there an identity element? Okay. So now what I'm looking for, is there a number that I can say 2/3 divided by this number is going to give me the same thing as that number divided by 2/3? And the answer should be 2/3. And there is nothing. So no identity element, and then there can't be any inverses. So in this case, nothing is working. And so that would be our final answer.